Hello everyone, I am Dr. Rajesh and I am again with you with my next video lecture. And in this video lecture we will study the problem based upon the resultant of two forces acting at a point. Now the problem is this problem that goes like, if the greatest possible resultant of two forces P and Q is n times the least. Let us say we have two forces, say one force is P and other is Q, and we have proved in the deduction section the greatest possible resultant is P plus Q, and this is the scenario when the two forces are acting parallel to each other. This is Q and this is P. In that case it simply adds up and give the resultant P plus Q. Now this is the greatest resultant we have studied. This is the greatest resultant. Okay. Now see, greatest possible resultant is P plus Q of two forces is P plus Q is n times the least, and in the same article we have studied that least resultant is P minus Q. Least resultant is equal to P minus Q. Now apply the given condition. If greatest possible resultant of two forces P and Q is n times the least, so what will be the case? It will be the case greatest possible resultant is n times the least. So this is the given condition and name it as equation 1. You could write it, this is the given condition. Okay, fine. I think up to here we are fine. Now read out the next part. Show that the angle between them, say alpha, let alpha be angle between them. Okay, so alpha be the angle. Now the next is the angle between them is this one when their resultant is half their sum. Let R be their resultant, and according to given condition R is equal to half their sum of the forces and half the sum. This is also the given condition. So we know that the formula for the resultant is R square P square plus Q square plus 2PQ cos alpha. Okay, fine. So I will be substituting the value from equation 2, that is P plus Q whole square is equal to P square plus Q square plus 2PQ cos alpha. This further implies that P plus Q whole square minus P square minus Q square is equal to 2PQ cos alpha. Now see, whatever we are going to find the value of alpha, there is involved no P and Q. Like here in this case P and Q are involving in each and every term. So we need to eliminate P and Q from here, and then we will be able to obtain the angle. Without eliminating, it is almost impossible to find the angle in the given form. Given form is angle is in terms of n only. So we need to eliminate P and Q. So we have no way out. We have utilized the condition number 2. To eliminate, we look at with some hope at equation number 1. And what is that equation? Equation is, come to the equation number 1. This is P plus Q is equal to N, P minus Q. So it will be P plus Q, P minus Q is equal to N by 1. So applying componendo and dividendo, C and D, componendo and dividendo. So what it will be? Sum of the numerator and denominator terms, the difference is equal to N plus 1, N minus 1. Q to Q will cancel out, and here P to P will cancel out. This implies that 2P is equal to 2Q is equal to N plus 1, N minus 1. 2 to 2 will cancel out, implies P by Q is equal to N plus 1, N minus 1, and I am going to name it as equation number 3. So we have to make use of this equation, P by Q is equal to N plus 1 by N minus 1, into equation this one. So but here how can it be possible? So we will take Q out from here and Q square from here. So see what happens. So this will be, I am going to take Q out, Q square, it will be P by Q plus 1 whole square, and this 2 will become 4 here. So this will be divided by 4, minus will be out, and I am going to take Q square outside. So it will be P square by Q square plus 1 is equal to 2PQ cos alpha. Okay, fine. So next what we'll do, we are going to take this Q down there in the numerator. This Q square from here will go into the denominator. So I am going to write the next step. Ultimately you will see what I am going to try. I am going to try is to put this equation in the form that each and every term contains the terms having P by Q. So this will be P by Q divided by Q square cos alpha. This will cancel out. So this will be 2P by Q cos alpha. So now using 3. Now you see P by Q is here, it could be used. P by Q whole square, this value could be used. P by Q is here, this could be used. So this will eliminate P and Q from this equation. So using 3 we will get 1 by 4 P by Q is N by N plus 1, N minus 1 plus 1, this whole square minus, okay, this will be N plus 1, this will be N minus 1 whole square plus 1, 2, this will be N plus 1, N minus 1, this will be cos alpha. Fine. So this implies that this will be further equal to N plus 1, N minus 1 divided by N minus 1 whole square minus N plus 1 whole square plus N minus 1 whole square divided by N minus 1 whole square, and the square braces. This is 2 N plus 1 divided by N minus 1 cos alpha. So this 1 to 1 will cancel out. So we are left with 1 by 2n raised to the power 2 is 4n square divided by n minus 1 whole square minus, open this square, n square plus 1 plus 2n plus n square plus 1 minus 2n divided by n minus 1 whole square 2 n plus 1 divided by n minus 1 cos alpha. So here you see this 2 n to 2n will cancel out, this 4 to 4 will cancel out. So this implies that this will be n square, and here from the denominator this n minus 1 will cancel out. So we are left with n square n minus 1 minus 2 n square plus 2 divided by n minus 1 is equal to 2 n plus 1 cos alpha. Here this 2n plus 1 will go into the denominator over here. So n minus 1, n plus 1 will be n square minus 1. So this implies that n square by n square minus 1 minus 2n square plus 2 n square minus 1 is equal to 2 cos alpha. Now taking this as LCM, this will be n square minus 2n square minus 2 is equal to 2 cos alpha. This implies that minus n square minus 2 by n square minus 1 is equal to 2 cos alpha. This implies the minus is common, 1 by 2 will, the 2 will come down in the denominator, n square plus 2 divided by n square minus 1 is cos alpha, implies alpha is equal to cos inverse minus 1 by 2 n square plus 2 divided by n square minus 1. The square brace is closed. So this was required to prove. This was required to prove. Okay, fine. You could once again see that cos inverse minus 1 by 2 n square plus 2 n square minus 1, this was required to prove. So this thing, cos inverse minus n square plus 2 divided by 2 n square minus 1, this was required to prove, and we have been successful in proving the result. Okay, so for the time being we have studied one important problem. So I would mark this problem as important from examination point of view. This is important problem, so you should thoroughly go through this problem, and in the next video lecture we will be studying another problem based upon the resultant of two forces acting at a point. Till then you go through this lecture, and if you have any problem you could ask me, drop me question in the YouTube comment section. You could ask me through my WhatsApp number. So whatever way you like, you could ask the question. So keep studying, keep learning. This is Dr. Rajesh saying you goodbye, take care, bye bye, and see you soon. Thank you very much.